right. Yeah, I am now. All right. So the phenol magnesium bromide is one of your start materials, and let's just stop there, right? The oxirane, formaldehyde, esters or alcohols from four carbon atoms. We don't really need to use that for this example for A. So what do you think? How would you break that apart, and what would your two star materials be? What's the strategy if we know that that Grignard that's given is one of our star materials? What's the strategy for
You remove the hydrogen from the oxygen.
going from here to here, right? Is that right?
Yes.
Yeah.
Okay. Now what?
You create the double bond and you kick off the methyl group.
Okay, good. You're right. We want to do this. I agree 100%. But do we want to kick off this side or do we want to kick off this side? Remember, we starting with, they gave us the Grignard.
Let's kick off the aromatic.
Yeah, they told us what Grignard that we can use, right? So we don't want to kick off the ethyl group on the other side because they already told us what we had to work to start with, the Grignard to start with, right? So we're gonna do that. Right? Is that right?
Yes.
Y'all have to excuse my dog. I don't know if y'all heard him coming down the stairs or not. And my son coming down here to fill up his water jug. I should have went. I should have done class where I normally do it. All right. So what does this Grignard look like again? Again, they said phenyl magnesium bromide. So how would you write that? Somebody write that in. No, don't all write it at once now. You might overload Zoom and make it crash. Okay. All right. Good. And that's important. Where the magnesium is, where the bromine is very important. You don't want to have the bromine attached to the ring. It's the magnesium that's covalently bonded to the ring, right? Uh, good. Thank you, Kayla, for putting that in. All right. So let me put it in here myself so it'll be in the notes when I upload them. Right. It's very important where the magnesium is, where the bromine is, where the bond is between carbon and the metal. Uh, that's important. All right. I'm gonna turn y'all loose on. I'm gonna turn y'all loose on D. but I'm not gonna do breakout rooms. I just want you to take a few minutes and work through it, and then we're gonna.
Is there just one way to do it, or is there two?
No, well, we gotta work from the. There are actually two ways to do it. Actually, you know what? Let's not bound ourselves in by just using that phenyl magnesium bromide. Actually, I want you to do two ways.
Okay.
Yeah, you can. Thank you for saying that.
Yeah.
All right. And if you want to share your screen, then we can do that too. I hope you like Jimi Hendrix too. And I want you to put D on a separate sheet so I can collect it. I'll put a link up to collect it today. It'll be due today by 5 as a bonus question. And showing both ways to make it. Yeah, I can. I see your question, Kayla. Yeah, I'll scroll back. You talking about the last questions we did at the end of class?
Yes, sir.
Yeah, we're gonna talk about those two before we log off.
Yes, please. Thank you.
All right. Because I want to make. I mean, I uploaded the notes the other day, but we can still go over it to make sure everybody got it. Everybody finished it.
Yes, sir. Thank you so much.
Yep, you're welcome. And this question that we're doing now, just apply the same strategy that we just did. But we're doing that to either. You can do that to either side. All right. Anybody got one way yet?
Yes.
Okay. You want to show it? I think who was that? You, Kayla, again?
It was me.
Okay. You got to clear off the other. And then somebody else can do just show one of your pathways, whichever one you pick, and then somebody else can do the second pathway to do the retrosynthesis. Okay.
Sorry that it looks so bad.
That's all right. So you want that arrow there, or you want it on the carbon where the bond is? Hold up, my bad.
Yes. Hold on. Can you, I don't know how to make it thicker.
That's okay. But you want it here, right?
Yeah, in that crease.
Like that.
Okay, it probably would have been easier to draw it that way.
Yeah, that's all right. That's my fault too, cause yeah. But I got you. It's because it's not gonna be on that top carbon. Those electrons, you want them on the carbon where the bond is. So you don't want not that. Sorry. I can't see it on my screen, so I'm having to kind of guess where to write.
Do you want me to erase it?
Yeah, you can take it off. Yeah. All right. Now, what are your two fragments that you're going to get from that? Okay, great. And that where those electrons are, that carbon is negative, yes?
Yes, and then you would just attach.
The magnesium.
Mm-hmm.
Gotcha. All right. Who's going to do the other side?
Do we have to draw the mechanism again, or can we just draw
No. You can just draw the two fragments.
Okay, I think I can do it.
Okay, come on with it. You can erase that, Kayla, because I'll write them in so that it'll be on the notes. Thank you for doing that. And let me erase my arrow too. I would just draw the ring first. There you go. Okay. All right, good. Yeah, we'll take that. We'll take that. That's exactly right. So for this, you can have this side that could be the granular or the phenylmagnesium bromide, which we started with, to be the granular. All right, good. Very good. Thank you. You can erase it and I'll write them in so that they'll be in the notes when I upload them. So you can start with this. Plus this. Or you can start with this benzaldehyde. Plus this granular. All right. Both of those pathways will give you the same product. All right. Anybody got any questions about this? I'm gonna go back up to the problems that I had y'all finishing on Wednesday, and then we're actually going to be done. I'm not going to start another section. So if we are, how do I erase that? All right, let me go back up to here. I think it was it here? The last two questions? So we had to do the first question here with the bromobenzene right here. Starting with that. Then we treat that with magnesium at low temperature, which is what's shown here. Magnesium in ether at 0 degrees, and then we get that granular. And I think somebody was asking me at the end of class Wednesday, but the Zoom timed out about the granular, about how to write it. You have to write the magnesium bonded to the carbon, right? It's gotta look like this, where there's that bond between the metal and the carbon. Otherwise, it's not an organometallic. All right. And then if you take that granular and add it to acetaldehyde and then treat it with an acid, all we're doing there is alcohol formation, right? If you remember that mnemonic from the video, GAKA, granular plus an aldehyde or ketone equals an alcohol, then this is what you're going to get, right? The acetaldehyde part is still intact. Don't panic about how it's drawn. All that is still there from here. Get a different pen. All right, questions about that one? Right, so that's just a whole sequence of reactions. You make the granular and then you use it in a reaction with the aldehyde to get the alcohol at the end. And if that's not clicking, you need to ask questions about it because you're going to see this on that exam. All right, what about the final one? All right, you see the alkyl halide here that we're starting with. Reacting that with magnesium in ether, 0 degrees. Why are we using ether again? Anybody?
Because to make a granular, you can't have a protic solvent.
That's exactly right. What happens to a granular in a protic solvent?
It becomes protonated.
Yeah, it's just like it will act just like a base, right? You have a proton around it. That's an excellent electrophile. So it's just going to snap those protons up and not even worry about reacting with anything else. So you can see here, I have my granular from that first step. And then I have an ester, right? So if I'm only adding 1 mole of granular to an ester, what should I get? An alcohol or a ketone? 1 mole now.
A ketone.
Ketone. That's exactly right. You get a ketone. If you add 1 mole, if you add 2 moles, then you're going to get the alcohol out after you quench the reaction, right? You have to have a quench step, right? But here you're going to get a ketone, right? And then if you add another granular, which is that next step in the process, then that ketone, and that's not completed. I should have numbered that, but let me do it now. We'll just use HCl again. Because you have to have that quench step in order to protonate that oxygen to get your alcohol. But if you add another granular to that ketone, then you're going to get an alcohol followed by a quench step. So HCl, ammonium chloride, acetic acid, water. You need some type of proton source. All right. Questions about that? About the last two questions there? So everybody got it. I think I uploaded this yesterday. So it should, not yesterday, Wednesday. So it should be up in Blackboard. All the notes are in Blackboard in that course notes folder. All right, no questions. So if we could take some time now, if you had questions, we got time. And if you don't have questions, if you're good, you know, you're gonna make 1,000 on the exam, then you can log out.
So for the bonus, you're gonna upload a submission folder and we have to submit it by 5 today.
Yeah, it'll just be a link. I can do that now since, let me open up.
What were the bonus questions again?
Really? I'm about to reach through this screen and knock your laptop off the table.
Sorry.
No, don't apologize. You ain't sorry. Sorry, not around. So my bad. The bonus questions were the questions we just did. That right here. Oh, hold up. You can't see that. Or can you? I think
A and D or just D?
both.
But I thought I must have.
Just leave. Dozed off.
No, like I had already done this, like when we did the handout submission because I thought it was due before class. So I had already done A and D.
Did you really?
Yeah.
On this question right here.
Yeah, because it's the retrosynthetic analysis.
Well, that's good. All you
So-
got to just take a screenshot of it and upload it
Okay.
to the new link.
All right.
And I take all my sarcasm back. I apologize for that. I'll be the bigger
It's
person.
okay.
Let me stop.
Do you mind scrolling up to the work that we did the other day?